Hey, welcome to the second installment of the Algebra 2 Semester 1 review. So for 26 it says use graphing to find the solutions to the systems of equations. You're just going to plug these into Desmos and you're going to get a text message. And then you're just going to look for the points of intersection, and what you're going to get is a parabola for the first graph, and then you're going to get, for the second equation, you're going to get a straight line. Wow, I do not know how much I missed on that. Yeah, I think I thought I was recording. I'm going to assume that we have, just to recap real quick, 26 and 27, you graph those on Desmos, and you're going to have a parabola on 26 with a line, and those points of intersection are going to be your solutions, and then 27 you have two parabolas, and those points of intersection are going to be your solutions. Then on 28 you count your terms, and we have 4 terms. 4 or more terms is a polynomial. And then on 29 what we did was I factored out a greatest common factor, or a common monomial, which was 6x, which left me with the trinomial x squared minus 10x plus 24. Now that trinomial could still be factored into 2 binomials, so I found factors of 24 that gave me negative 10, which were negative 6 and 4, and that left me with my factored form. Okay, number 30, it asks what are the real solutions. Real solutions are my zeros, or where it crosses the x-axis, and then how many imaginary solutions are there of my polynomial equation. So the real solutions, I'm going to actually give values for those, and then my imaginary solutions, I just need to tell how many. So I'm going to graph this. I'm pretty sure if I put it in this way, Desmos really isn't going to recognize it. So if I bring the 216 over with the x cubed, and put that in my calculator, then it's going to graph. And so I'm going to have something that looks like this. It's kind of does one of these things, and I guess it would be on the other side actually. Something like that. And so it only crosses the x-axis once, and so it has a real solution of 6, and I should have 3 solutions altogether because it has a degree of 3. So if I've got 1 real, that means I have 2 imaginary. Number 31 says how many roots do the following equations have? A root is just another way of saying solution. So root is equal to solutions. So I can have real solutions and I can have imaginary solutions. So I can have real roots and imaginary roots. I just need to know how many I'm going to have, and the degree is going to tell me. So if I have degree of 4, then I should have 4 roots. Some are going to be real and some may be imaginary, or all of one type. Number 32, I want to find the zeros of the equation. I want to put the entire thing in. Well, actually, when I do put the entire thing in, it doesn't quite work for me. It just gives me this error. So if I bring the 100 over with the rest of the equation and just subtract 100, and then put it in Desmos, it's going to work out. The zeros are strictly where it crosses the x-axis. And so in this case, it's going to cross the x-axis in 3 places, even though I have 5 solutions, which means that leaves me with 2 imaginaries. But I'm only worried about what my real solutions are. And so those are negative 5, 4, and 5. On number 33, you're also going to find the zeros. You should have 4 solutions altogether, but not necessarily that many zeros. When you graph it, you're going to end up having real solutions at -5 and 5, and then the remainder would be imaginary. Number 34, what polynomial has a graph that passes through the given points? So we've got 1, 2, 3, 4, 5 points there. We had a rule that however many points you have, the degree of the polynomial is going to be 1 less than that. So we're looking at a polynomial with degree of 4, which is going to be a quartic polynomial. Okay, 35. We're going to multiply and then simplify as much as possible. So we've got the square root of 7x times the square root of 7 minus 7 square root of 7. You got to do the distributive property. And you're going to have, since they both have radicals, you're going to have square root of, and you're going to have 7x times x, which is 7x squared. And then -7, square root of 7x times 7, square root of 7 is square root of 49x. So that's what we have so far, but then we have to see if it can be simplified anymore. I can take the square root of x squared in the first term, and I can take the square root of 49 in the second term. I can't take the square root of 7, so I'm going to leave that. I'm going to have an x out front, square root of 7, minus, I still have the 7 on the outside there, and then square root of 49 is 7, and I have the square root of x. It can be simplified just a hint more by multiplying here, and so I end up with x square root of 7 minus 49 square root of x. For number 36, they both have the same radical, so I can actually put the whole thing under one radical sign and have 90x to the 18th over 2x, and then I can reduce that. So I have 90 divided by 2 is 45, and 18, or x to the 18th over x is x to the 17th. You just subtract those exponents. Then I'm going to look to see what I can take the square root of. 45 have factors of 9 and 5. And to take the square root of an x term with an exponent, I need an even exponent. And I can divide that up and have x to the 16 times x. That's the same as having x to the 17th. So the square root of 9 is 3. I can't take the square root of 5. The square root of x to the 16th, we simply divide the exponent by 2, and that's x to the 8th, and then we've got a square root of x. So I have 3x to the 8th square root of 5x as my solution. Okay, 37. A garden has a width of square root of 13 and a length of 7 square root of 13. It wants to know what the perimeter of the garden is in simplest form. So perimeter, we're just going to add up the 4 sides of our garden, go all the way around. So we've got perimeter is the length plus the width plus the length plus the width. So 7 square root of 13 plus square root of 13 plus 7 square root of 13 plus the square root of 13. We're just going to add all those together. Since they all have a radical, rad 13, we can just add the numbers in front. So we've got 7 plus 1 is 8 plus another 7 is 15 plus another 1 is 16 square root of 13. And that's my solution. Number 38, what's the product of the radical? Remember, when you square something, that means to take it times itself. So we can rewrite it as -5 minus the square root of 3 times -5 minus the square root of 3. We're going to do the FOIL method, first, outer, inner, last. So that's going to be 25. The outer term is in positive 5 square root of 3. The inner term is positive 5 square root of 3. And the last term is positive square root of 3 times square root of 3. That's squaring a square root, which leaves me with just a 3 there. And then I combine any like terms. So that's going to be 25 and 3 is 28. And then 10 square root of 5 plus square, 5 square root of 3 plus 5 square root of 3 is 10 square root of 3. Okay, number 39. What is the solution of the equation? So we're going to have to do a little solving. Here we want to get the radical by itself, so I'm going to add 6 to both sides. And I end up with the square root of 2x plus 8 equals 2. And I want to get rid of that radical. I'm going to do that by squaring both sides. Now remember, when you square both sides of an equation, it can result in extraneous values. So you always want to check for that. So that leaves me with 2x plus 8 equals 4. And I'm going to solve for x. So subtract 8, that's 2x equals negative 4. Divide by 2, x equals negative 2. There's only one solution there. We just want to double check and make sure that it actually works. So I've got 2 times negative 2 plus 8 under the radical is 4. The square root of 4 is 2, and then 2 minus 6 is negative 4. So that works just fine. So my solution is negative 2. Alright, number 40, it says, what's the solution of the equation? And again, we're going to eliminate extraneous values if there are any. Both of these are to the 1/5 power on both sides of the equation, so I'm going to take both sides to the 5th power, just the reciprocal. And all that's going to do is leave me with the base, which in this case is negative 2x plus 6 on the left and negative 8 plus 10x on the right. And then I'm going to solve for x. So I'm going to subtract 10x, which gives me negative 12x plus 6 equals negative 8. And subtract 6, which is going to give me negative 12x equals negative 14. Divide by negative 12, x equals 14 over 12, which is 7/6. I'll give you a hint, that's the right answer. But you can always check and make sure that if it's an extraneous value or not. Same thing with number 41. We're going to square both sides to get rid of that radical. Now be careful, because I saw lots of people do this. You have to square 5x. So you're squaring the 5 and the x. That's 25x squared. On the right side, the radical's gone, so I have 10 plus 15x. Now since I have a squared term, it's not just going to be, there's not just one x there. There's actually 2 x's. So I have to bring everything over to one side, and I can do the quadratic formula with that, or factor it, whatever I want to do. So I'm going to subtract 15x from both sides, subtract 10, and here's my equation. So again, you can use the quadratic formula to solve, or you can factor, whatever you want. And then on 41, when I use the quadratic formula, I'm going to get 2 solutions. I'm going to get x equals negative 0.4 and 1. But what I find out when I substitute the 2 in to check to see if I have any extraneous values, this one does not work. So I actually only have one solution, and it's 1. Okay, number 42. Let f of x equal x plus 2 and g of x equals x squared. We're going to find g of f of negative 5. So we always work on the inside out. So the first thing we're going to do is take the f function and put negative 5 in it. That's what it says. And then when we get an answer for that, f of negative 5, we're going to put it into g. So let's do f of negative 5 here first. All that means is that in the f function, we're going to replace the x with the negative 5. Okay, so the x is going to become negative 5 plus 2, which means that f of negative 5 is negative 3. Okay, so that means now I'm going to take g of negative 3 because f of negative 5 is negative 3. So I just replace that with the negative 3. Now in the g function, I have g of negative 3. I'm going to replace the x in the g function with a negative 3 and get negative 3 squared, which is 9. So basically it's substituting twice. And so my answer is 9. Number 43, graph the relation and its inverse and use open circles to graph the points of the inverse. So basically we're going to put our set of ordered pairs on a coordinate plane. Okay. And so I have my first one, I'm going to have, actually I'm going to put mine, the original relation in green. And I have 0, 3, which is going to be about right there, and 4, 2, and I have a 9, 7, and a 10, negative 1. Okay, and then the inverse is just where I flip basically the x and y trade places. Let's do that in red. So the x's that I originally had become my y's, and my y's become my x's. So the x's are now 3, 2, 7, and negative 1. And their corresponding y's are what the x's were, which is 0, 4, 9, and 10. Okay, and then we're going to plot those. So now I have I think I put one of my points in the wrong spot. Okay, let's back up, and the original point is 0, 3, so it's up here somewhere. Okay, now we're ready to do the red ones. 3, 0 is right in there. 2, 4. 7, 9, and then negative 1, 10 would be up here somewhere. Get real fancy. So that's how you do an inverse. Number 44, what is the inverse of the given relation? So ordered pairs are really easy. We just swap the x and y's. When you have an equation, you are going to swap x and y's. You're just going to swap x and y's in the equation. So the first step would be to switch x and y so that instead of y equals 7x squared minus 3, we have x equals 7y squared minus 3. And then we're going to solve for y. You're going to add 3 to both sides and get x plus 3 equals 7y squared. And then divide both sides by 7, so that gives you y squared equals x plus 3 over 7. And then to get y by itself, you got to take the square root. And so now I have y equals, and this is the, make sure you don't forget this, so when you take the square root, you're going to have plus or minus the square root of x plus 3 over 7. And I'll let you leave it that way, even though we would technically have a denominator in the radical. But there would be my inverse. Okay, 45. We're going to do the same thing. We're going to write our inverse. So we're going to switch first the x and the y and get x equals negative 4y squared minus 2. And then you're going to solve for y. So add 2, that gives me x plus 2 equals negative 4y squared. And then divide by negative 4. So x plus 2 over negative 4 equals y squared. And then you're going to take the square root. Again, you're going to have plus or minus. So y is plus or minus the square root of x plus 2 over negative 4. And then you have to graph it. And here's this, that's kind of the tricky part. So I'm going to show you how to graph this on the coordinate plane. Okay, so I'm going to graph the original function, and that's y equals negative 4x squared minus 2. And you can see there's that one. Okay, the inverse should reflect across the line y equals x. Okay, so now I'm going to do the inverse, but I've got plus or minus, so I actually have to put it in twice, one with a plus and one with a minus. So I'm going to take y, make sure you're in the right box, y equals, and for the positive version I'm going to take the square root of, and I'm going to put parentheses around this so I have my numerator is x plus 2. And then I'm going to go outside the parenthesis but still under the radical and hit the division sign, and that'll give me a denominator where I can put negative 4. Okay, and you can see that when I only graph it without the minus, that I only have half of it. And you can't put plus or minus on this. You have to do it separately. And then I'm going to put y equals, in the negative version, so minus the square root. And again, divided by negative 4. And now I have the whole thing. So that's the inverse. But make sure you do the positive and the negative. Okay, there's your study guide, and good luck on the test. Just to make a note, and I'm going to send out an announcement on this as well, but you can use a note card, 3x5 note card, with stuff on the front and the back. And you can use Desmos, so make sure you bring your laptop. And I will see you this week.